Okay, lads, how are you? Good afternoon. It's a bit strange teaching you online, but the format is I'm going to post a short video every time I have you for class, explaining what we're going to do in the lesson, and what will follow then will be a short assignment for you to complete during class time. I would expect the assignment to be completed by the end of that school day. So if I post an assignment on today, which I will after today's lesson, you have until the end of the day to submit it. Everybody on Google Classroom will get the assignment posted to them in their individual assignment window, and then you return a picture of your answers to me or submit your answers by the end of the day. Now, in some cases, you may not be well enough. Hopefully, that isn't the case. You may not be well enough to complete the work. What I need you to do is I need you to tell me. I need you to send me a message on Google Classroom to say whether or not you're feeling well enough and you can complete the work. So if you're not feeling well for any reason, if you just post a message, and then I know that I'll not be expecting any work from you. If work hasn't been turned in, and I haven't heard anything from you, then I will be contacting home. I have a list of all your parental emails and phone numbers, so I'd expect you to complete the work if you're well enough. And as I say, if it's not completed, I'll be contacting home to find out why. I'm sure you heard the announcement about the exams being cancelled this year, but that doesn't mean you won't be getting your GCSE statistics grade at the end of the year. What I'll be looking at is I'll be looking at your work throughout the course of the year, the work you're submitting, the standard of it, your levels of engagement, and obviously that will go towards your final grade. We don't know how that's going to be formulated yet, but there's no doubt that your work throughout the course of the year will have a significant impact on what you're going to achieve in statistics at the end of the year. We've covered the foundation course in the first term up to Christmas. So as I explained to you, what we're going to do now is we're going to look at the higher topics, because what I want people to be entered for the higher tier in the summer, and that'll allow them to achieve the top grades if they can complete the work successfully. So the first topic today is to look at something called Spearman's rank correlation coefficient. Okay, it's written at the top of the page there. And it sounds complicated, but basically all it is it's looking at two sets of data. So that would normally be plotted on a scatter graph. So it's looking at those in a table, and it's measuring the strength of the correlation between the data. Okay, so just as an aside, we know, if I look at this page with you, we know that correlation comes in three ways. You can have a positive correlation. That is where if you draw a scatter graph of the two sets of data, so if you have data A plotted against data B and it goes up in this direction, you can draw a line of best fit that goes like this through the points, and that would be positively correlated. Positive correlation. Okay. On the other hand, what that means is that this variable A is increasing as variable B is increasing. So they're both increasing together. So as A gets bigger, B gets bigger. Okay. You can also have negative correlation, where the points, if you plotted them on a scatter graph, would go downhill like this. Where if you had variable A and variable B, it means as variable B as variable A gets bigger, variable B gets smaller. Okay, and that's called the negative correlation. Negative correlation. Okay, this is where two variables are linked. So this could be A and B could be the height and the weight of somebody. So as people are taller, they're usually heavier. Okay, and that those two things could be positively correlated. Negative correlation could be the depth of tire, or the amount of miles you travel in your car against the depth of tire tread on the tires. So the more miles you travel, the tire tread gets smaller. Okay, so it'll be a negative correlation. You can get things that aren't correlated at all. There's no relationship between them. So if you go A and B and you were to plot those, in other words, if you plot the actual dots on a scatter graph, they're basically, they don't represent any sort of correlation. They don't lie on any line, and you couldn't really draw a line of best fit for this data. So there's three types of sorry, that's no correlation then. That's the third one. So this could be the amount somebody earns against their height, which they're not really linked. Okay, there's no link between them. So what Spearman's rank correlation coefficient does is it measures how strong the correlation is. Okay, and there's a formula for it, and I'm going to show you how to actually work out the value of the correlation coefficient in order to measure how strong the actual correlation is. So the value that you'll get for Spearman's rank will lie between, we call it R, okay, the letter R really represents the value of Spearman's rank. It lies between -1 and +1, okay? So whenever you work out Spearman's rank, your answer will be between -1 and +1. If you get an answer outside of that range, then it's not correct, okay? So, but if you get an answer of -1 or close to -1, okay, so let's say your answer was -1 or -0.9 or -0.8, answers like that, they're close to -1, that would mean that it's a negative correlation, okay? And the closer you get to -1, the stronger the correlation is. The stronger means that the points lie nearly in a straight line. So it's a very strong negative correlation if your answer is close to -1. Okay, now if your answer is -1, then it's a perfect negative correlation. But if your answer was 0.9, then it would be very strong negative correlation. Okay, if your answer was close to 0, if your answer was close to 0, then that would mean there's no correlation. Okay, there's no correlation. So a Spearman's rank answer of 0 would mean there's no evidence that the two variables are linked in any way or are correlated. There's no relationship between the two. A bit like in this diagram here, where you have the points scattered all over the place and there's no real pattern to them. They don't lie in a line. Okay, if Spearman's rank answer is close to 1, so if R is close to 1, let's say it was 0.9 or 0.7 or 0.8, those would represent positive correlations. That's a positive correlation, and that's like this diagram up here. Okay, so the closer you are to 1, the more strong it is in terms of a positive correlation, so you can comment on the strength of it. So an answer of 0.9 would be a very strong positive correlation. Okay, now what you can do is you can represent Spearman's rank on a scale. Okay, so if we draw a scale out and we say there's -1, there's 0, and there's 1, and this is R, which is our Spearman's rank value, right? And if I do an X here and an X here and an X here, okay, I would comment on this one, okay, that's very close to -1, and I would say that is a strong negative correlation. Okay, it's strong negative correlation because it's here, it's just probably about -0.8, it's close to -1. This value here is just above 1, okay, so it's probably about 0.2. That is a weak positive correlation. What weak positive correlation means, it means the points lie in a positive correlated pattern, but the points are scattered about a wee bit. So if you look at these two diagrams, I'll show you the difference, right? This one would be a weak positive correlation, okay? That one, because the points do lie in a correlation that goes up positively, but the points are a bit scattered. This is a strong positive correlation. Okay, this one here, because the points are more linear, they lie tighter together in a line. So this is strong positive, this is weak positive. So this would probably have an OR value of 0.9 and this would have an OR value of 0.2. So you can see the difference in the pictures. This one here is a very strong positive correlation. That's about 0.9. So this is strong positive correlation. Okay. So now you know whenever we work out Spearman's rank, and I'm going to show you how to work it out. It's easy to work out. You will get a number for your value, but you need to know what the number stands for. If you get a number of 0.9, it means it's very strong positive correlation. A number like 0 would mean there's no correlation between the two, and a number that's negative means that it's a negative correlation. But the closer you get to -1 and +1 means it's getting stronger, the correlation. So an answer of -1 would be a strong negative correlation, and an answer of +1 would be a strong positive correlation. So in the next part, I'm going to show you an example of how to work out the correlation then. Okay, so what we're going to do is, first of all, look at the formula for it. Okay, and this is given on the formula sheet in your exam. So R is the correlation value. It is 1 minus 6 times the sum of d squared over n times n squared minus 1. Now don't worry about this at the minute. I'm going to explain to you what d means, and then d squared, and I'm going to explain to you what n means, and then this is called sigma, this symbol, which means to sum them up, So I'm going to show you an example here which takes you through exactly what you need to know. What we've got is in this table, right, it's an investigation into smoking where we talked to 8 patients and they were assessed for the amount of lung damage that they had suffered and were asked how many years that they had been smoking for. So lung damage is X, that's the value of X across the top, and the years they were smoking is Y along the bottom. So what we're asked to do with this data is we're to see if there's a correlation between the two sets of data. Now we would expect this, if you think about it, right? The lung damage, if it was greater, if somebody had a lot of lung damage, you would think that they had spent more years smoking than if somebody didn't have a lot of lung damage. I mean, they maybe didn't smoke for too many years. So I would expect an OR value here to be positive, but we'll have to work it out. So the first thing, and this is the first step in working this out, is we need to rank these numbers here. We need to rank them. Now ranking them means taking the smallest number as the first ranked value right up to the largest number as the last ranked value. So here's all you need to do, right? And this is the way I would do it on a table. You look along X, this is the lung damage values, right? And you take the smallest value, which is 6, and you put that as number 1. Okay, you put that as number 1. Then you take the next one up, okay, which is going to be 12, and you put that as number 2. So that's we're ranking these, that's number 2. Then you take the next one up, which is 23, and you put that as rank number 3. Okay. Then you take the next one up, which is 42, okay, and you put that as rank number 4. Then you take the next one up, which is 44, and you put that as rank number 5. The next one up is 56, that's rank number 6. The next one up is 58, that's rank number 7. And the next one up is 83, that's rank number 8. So a simple exercise, what you do with the first set of data on the top is you rank them. So number 1 would be the smallest value up to number 8, because we've got 8 numbers there, is the highest. And notice how I rank them. I rank them with a wee bubble. I put a number and a circle it, so I have the ranks at the top. We're going to do the same on the bottom for the Y values. We're going to rank them, but what we're going to do is we're going to do them exactly the same way, where number 1 is the smallest value up to number 8 being the biggest value. So we look for the smallest value, which is 13. That's going to be number 1. The next one up is 14. That's going to be number 2. The next one up is 16. That's going to be number 3. The next one up is 17. That's going to be number 4. The next one up is 18. That is going to be number 5. The next one up is 19. That's going to be number 6. And the next one up is 22. That's number 7. And the next one up is 25. That's number 8. So what we've done is we've ranked the top and we've ranked the bottom, and we have them in bubbles there. Okay. Now, you'll notice in the formula there's a letter D. What that D stands for is the difference in the ranks, where you take the ranks away. So I'm going to add a D line along the bottom here, and what I'm going to do simply is take these two numbers away. See the 4 and the 3, the two ranks here. So all you need to do is subtract them. Now, it doesn't matter what order you take them away in, because we're actually going to be squaring the ranks. So what you do, the difference in the ranks, so what you do is take these away. 4 minus 3 is 1. That's 1, 5 and 6. 0. That is 5. That is 1. That is 4. That is 3. And that is 5. So all I've done is looked at the two ranks, top and bottom, in the bubbles, and I've subtracted them. And that is going to be your D value. What you're going to do underneath that is you're going to work out D squared. And all you're doing there is, see the values for D you have? You're just squaring them. So that's 1, 1, 0, 25, 1, 16, 9, and 25. Okay, so all I've done to get D squared is I've taken my values of D and I've squared them. Now, you'll notice in the formula you've got sigma. I mentioned that earlier. That means to add them up. The sum of. So you see, when you see that, that means add, or to get the total of them. So what we're going to do is I'm going to work out sigma D squared, which is where you add the D squared values all together. So this is 25 and 25. I'll underline them. That's 50. 50 and 10 is 60. 60 and 16 is 76. 76, 77, 78. Okay. So what I've done is I've worked out the ranks. I've taken them away. Okay, I've taken them away here. That's my value of D. I've squared it to get D squared. Okay. And then what I've done is I've summed them up, and I've got 78. Now you'll notice as well in the formula you've got N, a value of N. All N stands for is the number of numbers in each row. So N in our case for this is 8. So in this value, N equals 8, because we've got 8 numbers we're dealing with in each row. So we've got the information now to work out the value of the Spearman's rank for this data. So what I'm going to do is put this into the formula. Okay, and you can use a calculator here if you need to. So R is going to be 1 minus 6 times 78. That's your value of sum of D squared, divided by 8 times, now N squared minus 1 is 63. Because that is 8 8s are 64, minus 1 is 63. So you can see the way I have that written out. So I'm going to type this into the calculator and see what I get. I get 6 multiplied by 78. That's 468. So it's 1 minus 468 divided by, so 8 multiplied by 63 is 504. So let me work that out then. 468 divided by 504. Okay, and that's 1 minus, so 468 divided by 504 So I'm getting 0.0714 for R. Okay, so what that's telling me, that value, is it's actually a very weak positive correlation, as I mentioned before, because what you can see is that the value is positive, right? But it's close to zero. So it's not like 0.9 or whatever, it's just above naught. So it would be a weak positive correlation. Okay, weak positive correlation. So that's how you work out the answer. So the video is quite clear. It shows you how to do it, and it shows you what the value of R means. Now, your assignment for today is this one question underneath, okay? And I'm going to post it separately as a picture on Google Classroom for you to complete. But it's about a skater. The table shows the marks given by 2 judges to 6 skaters in an ice skating competition. So you've got skater A down to skater F. So judge 1 gives skater A 6.5, etc., right? And judge 2, you can see them listed. So we want to see if there's a correlation between the judges' scores. So what you need to do is you need to do what I did above. You need to rank these from the smallest to the biggest, and same underneath, and you need to work out Spearman's rank. And then I want you to comment on the correlation, okay? So hopefully you find that easy enough to do, and that'll be the first task. I'll post it on for you now, and good luck. If there's any problems or questions, you can just message me on Google Classroom and I'll get back to you. Thank you.